The scientific method is about ordinary people doing ordinary things. That includes you, me, and other scientists in the world. The scientific method is just a process or steps taken to produce reliable results to answer a specific question. Maybe you don't think you use the scientific method in your life, but I can probably guarantee you do. For example, imagine you wake up on a Saturday and you can't find your cell phone. That's an observation. Then you do a little research by trying to remember the last time you had it. You suspect it might be in the pocket of your jeans. You've just made a hypothesis. When you check your pants, you're doing an experiment. But no luck. Your phone is not in the pocket of your pants. So your second observation makes you think again and recall what you did yesterday. You remember that you put your cell phone in your backpack, so you decide it must be there. So you go and check. Lo and behold, there it is. You're so happy, you want to share your excitement with your best friend. You share your results. These are the steps of the scientific method: observation, research, hypothesis, experiment, conclusion, and share results. You can go back and repeat these steps at any time, especially if the results were not what you expected. Observations and research are an ongoing thing. Science is a continually ongoing process. Let's look at each step. Observation. We use our 5 senses to make observations. The 5 senses are smell, sight, taste, touch, and sound. Research. Research is an important step because it may answer other questions you have and help you refine or redesign your experiment so you don't waste your time later on. Make sure you use reliable resources to learn your background information. Scientific journals and online information are best. Avoid blogs and out-of-date textbooks, as the information might not be reliable. Hypothesis. Once your research is completed, you can form your hypothesis, which is a prediction of what you believe will occur. It is often seen as an if-and-then statement, and is very specific. For example, if gummy bears are placed in water for 24 hours, they will swell to over twice their size. This statement uses if and then, and makes this experiment repeatable. The experiment itself is made of several parts. You will collect 2 types of data: qualitative and quantitative. Qualitative data relies on descriptions like soft, yellow, shiny, or wet. Quantitative relies on numbers like 2.5 centimeters or 23 grams. Once you know what types of data you're going to collect, you can define the variables. There is an independent variable, which is the thing that you will change to see how it affects your dependent variable, which is what you measure. In the gummy bear experiment, the change in the experiment is that the gummy bears are being placed in water. The dependent variable is the volume of the gummy bear, which is measured before and after it's soaked in water. A valued experiment will have both an experimental group where one independent variable is altered and a controlled group, which can be used to compare the experimental group to the normal or unaltered version. Again, using the gummy bears, the bear placed in the water is the experimental group and the dry gummy bears are the controlled group. So to summarize, an experiment should have an experimental group and a control group. The experimental group will have an independent variable and a dependent variable. The data that is measured and collected will be either qualitative, quantitative, or both.